Good morning, all of you. Today we are going to see about the topic Geiger Muller counter, radiation detectors. So, what are radiation detectors? Radiation detectors are the detectors which are used to identify the radiations. Basically, the radiations here, what we are talking is about alpha, beta, gamma radiations. So these are the radiations which are evolved from the different radioactive elements. The radioactive elements basically indicates uranium, plutonium, titanium, cesium, francium, etc. So all these are the elements which basically evolve these radiations. Those are alpha, beta, gamma radiations. The radiations which are emitted by these elements are called as an radioactive elements. Sorry, the radiations which are emitted by these elements are called as an radioactive radiations or radiations. So these radiations which are being detected by using some types of detectors which are called as an radiation detectors. So uh, the detectors which are basically used for these identification of radiations alpha, beta, gamma are, the first one is GM counter, ionization chamber, scintillation counter, and solid state detectors. So these are the different types of detectors which are basically used for identification of these radiations. Now, if you see the first one, that is GM counter. GM counter basically is nothing but Geiger Muller counter. Geiger Muller counter, which is used to identify beta and gamma radiation. Sometimes we can also use for alpha particles or alpha radiations. So this was introduced by Geiger and Muller. So what is exactly a Geiger Muller counter, how it is used, what is the working principle, we'll see now. So Geiger Muller counter basically in hollow cylindrical tube filled with the gas, that is, we are calling it as an ionizing gas. So these are also called as an gas filled detectors. So these GM tube, we are calling whatever it is, these GM tubes are closed at N1 and open at the other one, and this opening is done with the help of mica, which acts as a window. The other side is closed. This external surface acts as a cathode, and a small lead wire is taken, which acts as an anode. And we are giving a supply for this one. You take output here, and this is resistance. So here the particles which are to be identified are allowed to pass from this, and these particles which are coming out from the source, okay, are enter into the chamber, that is GM tube, where here these particles, beta or gamma particles, will get collide with this gas molecules, that is you're calling, which is called as an ionizing gas, will be colliding with these alpha particles, and then ionization takes place. Thereby it divides into positive and negative. They go and deposit it on their respective anode and cathode. Once they get deposited, a small amount of voltage or current, a small amount of current is being generated, and that generated current is passed through this resistance. Thereby you will be taking output across this resistance. What are the output you will be getting here is taken, amplified, calibrated in terms of your alpha particles or beta or gamma particles. So the process of converting these particles into voltages is being done, or identification of these particles is being done here with the help of your GM counter, which is called as a Geiger Muller count. So thank you for it. In the next class we see about what is ionization chamber and etc. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.